welcome back to day 3 of the Red Hat Summit. You know, a lot of us have been doing this for a long time, and it's just amazing. But it seems like today that technology is moving faster than it ever has before. And it makes you really wonder, right? As a technologist, you really wonder: is the technology changes that are happening? Are we the ones that are responsible for the business transformation, or really is it the direction that these businesses want to go? That they're putting requirements on those of us in technology and then evolving us faster. And I suppose perhaps it's a bit of both. But one thing that I think that's abundantly clear is that IT departments are in the middle of all this, and the expectations on our own IT departments have never been higher. So meanwhile, though, they're rewarded with these increased expectations with these budgets that are either shrinking or, in best case, flat. And then, as Jim was talking about earlier, over 80% of the existing spend in IT is actually spent just on the legacy technologies and applications, just keeping the lights on. So trying to challenge IT departments with both either time or dollars to actually invest to actually get out of the hole is a really difficult thing to do. And so you think about it a little bit from what developers are doing today. Today's developers are not doing what yesterday's developers were. Today's developers, just think about the resources they need. I remember back when to develop applications, it just meant a workstation under your desk, and when you're finally done, that application just ran out of desktop. Today, developers have an insatiable appetite for physical resources, computers, and storage to not just develop their applications, but then just to test them and deploy them at scale. And you look at what's going on inside these app stacks, right? The technology inside the application stacks of these modern apps is not the same. A lot of this technology didn't even exist 5 years ago. Look at what's happening in some of these new mobile frameworks, right? And then some of the NoSQL databases. So now you got a whole new stack of technologies that developers are using, and a lot of that isn't even yet blessed by IT departments for use. So then you look at sort of businesses, right? We're in an all-connected world, and so for businesses to compete, it's all about customer engagement. And so how do businesses drive customer engagement? They need applications and services continuously deployed in order to drive that. So IT is the guy in the middle, right? So they're really caught in the middle. They're sort of challenged with meeting the needs of the developers. They're challenged with meeting the needs of the lines of business. And so meanwhile, there's these external IT departments, these big public clouds that today are actually able to service developers better than our own internal IT departments. So it absolutely seems like this insurmountable task, but that's what open source is great at. It solves really hard problems. And so sort of look at where we've come in building an open platform in the way of Linux. Where would IT even be today without Linux? And so when you start to look at sort of the next generation and the evolution of all the cloud technologies, I think it's really easy to see that open source is at the forefront. So I want to go back a little bit and talk about where we pick up from where we left off last year. And so last year we really talked a little bit about the evolution of IT. And one of the things that we touched on is that the specialization that's happening in hardware is going away. And so what we're not saying is that innovation is done, right? The innovation in today's hardware platforms are often about better performance, better power management, better security. But the way IT departments are consuming that hardware technology is part of a standardized package. And the majority of today's innovation, whether it takes place in hardware or at the application level, is fundamentally driven by software. We also talked about the 3 vectors of IT: compute, storage, and network, right? And that increasingly open source Red Hat Enterprise Linux and x86 were delivering that on standardized platforms. But I think what's new is that it's no longer, we spent, even at Red Hat, the first 10 years of just replacing legacy, fitting into that footprint and replacing it. But now what you're actually seeing in open source is we're at the forefront of driving new capability inside of these IT departments. But we didn't answer the second question last year. We talked about compute, storage, and network, how it's going to be software-driven on standardized hardware platforms, but we didn't talk about how to knit it together. We didn't talk about the architecture of that fabric and how you really actually delivered on that dream of this agile enterprise. Today we know that answer, and the answer of that architecture to integrate compute, storage, and network is OpenStack. So what OpenStack is really about, it's a collection of projects, and the projects are all about how do you build these infrastructure as a service clouds. And what's nice about it is it's not one company. It's actually developed globally by a lot of companies and a lot of developers. The last release came out a couple of months ago, and that had over 517 developers, the amazing part, at different companies all contributing. So I want to tell you a little bit about how Red Hat got involved, and I think, in truth, how we actually almost didn't get involved. It really started for us back in 2010 when Rackspace actually kicked up the idea of OpenStack. And so I actually got a phone call from Jim Curry, and what he talked about, he had a pretty big ambition, right? He was going to build he and Rackspace were going to build a ubiquitous cloud computing platform. It was going to be great at building private enterprise clouds. It was going to be great at building, and running public clouds. You could use it in small scale, but it was going to have near infinite scalability as well. And it was going to be simple to deploy and manage, right? So a monstrous goal, but even at Red Hat, and a big believer in open source, we weren't yet a believer. It took about 10 months, and about 10 months later, in 2011, a lot of the early things that Jim talked about were starting to come true. OpenStack in 10 months had become, there was this global awareness of just the brand. And then in addition to that, it wasn't just Rackspace anymore. The developers from around the world, it started with NASA and Rackspace, but developers outside of those two companies were really getting involved in pushing it forward. So in July 2011, we responded, and you got to take that first step, right? So we assigned one developer to actually start working on OpenStack. There was our team. So then in August, though, we realized we were going to completely pivot on OpenStack. And by pivot, what I mean is we actually said we're changing. This is disrupting us. We're going to change our efforts. We're going to change our technology stack and our technology investments. We're going to change the teams we build. We're going to change our product strategies. We need a whole new set of services and a whole new set of partners. And then actually a day later, after that memo went out, the first changes from Red Hat were actually accepted into the OpenStack public trees. And that work was actually the culmination of that prior month by a really awesome engineer at Red Hat named Mark McLaughlin. So rather than me tell you more about Mark's story, I want to let you hear it directly from him.
So I first learned about OpenStack in July of 2010, and NASA and Rackspace had brought together a group of 100 developers in San Antonio, Texas, to really kind of kickstart the project and get the project going. They were really doing everything right. Everything looked like there was a bunch of really smart guys involved building a project exactly the way I'd like to build a project. Towards the end of July 2011, Chris Wright, who you're also going to hear from in this session, just happened to be visiting Ireland with his family. We headed off over there to Hoth Summit, and we basically had a couple of pints and went for a walk on the cliffs. We're really just talking non-stop about OpenStack and how successful it is and how it was growing so much and how we really needed to be involved. So that Monday morning after Chris had flown home, basically down tools on everything else I was working on, stopped checking my email and just really completely focused on the initial task of getting OpenStack into Fedora 16. In August 2011, when Brian sent out his memo, it was literally just me contributing to OpenStack. I think I'd got my first patch into OpenStack the day before Brian sent his memo. But since then, we've grown the team massively, and I think in the last release, we had over 30 developers from Red Hat contribute to the release, and we were actually listed as the #1 contributor to the release in terms of the number of commits. In the Grizzly release, we have two new projects. We have the Heat project and the Ceilometer project. Heat is about application orchestration, and Ceilometer is about metering. And this is really kind of extending, what OpenStack is about, just beyond the really core compute and storage and networking resources that the project started with. I think OpenStack has great potential for the future. We're really still in the very early days of OpenStack, and I'm really excited to see both the project mature in terms of its core components, but also that we're constantly adding new components to really build out the capabilities of OpenStack.
So then later that same year, what OpenStack does is they actually have twice a year, they have what's called design summits. And the design summits are really about forward planning the next release. So the fall of 2011, there was what was called the Essex Design Summit. And so that was actually the first OpenStack summit that Red Hat participated in. It actually happened right here in Boston. And then also, Rackspace wasn't done. The idea of creating this global community was awesome, but they realized to really get massive adoption of OpenStack, they needed to federate the governance as well. So they started sort of calling us up and kicking up the idea of what if they took all the governance of OpenStack, which means the brand, the copyright, and the control, and push that out as well. And then in 2012, in spring, the Essex release was delivered. So that was the first OpenStack release that actually had some Red Hat code inside. And then in addition to that, Rackspace was true to their word, and they actually spun out an independent foundation around OpenStack. Red Hat and IBM and HP and others all joined in, and Red Hat joined at the platinum level, which is the highest level of participation. And so then that fall was the Folsom release, and at that point in time, we gave Mark some help, and we started building a real team around OpenStack, and it was a really solid team. And by fall, the release of Folsom, we became the #2 developer. And so then, so it brings us into 2013. So those of you watching, 2 months ago in April was the release of Grizzly. So that's the most recent release of OpenStack. And by that time, the same team got a little larger, but they also just the impact they made is just amazing. It's daunting. Red Hat became the #1 developer of OpenStack. But to us, it really just still feels like day 2 because we just see all the things that we have, all the things that it could be. So we're going to continue to make, additional investments in it. And we just think that OpenStack holds so much promise for the future. And so for us, it really is the early innings for OpenStack. But we've been there before. It really reminds us a lot of, being, part of enterprise Linux 10 years ago. So getting back to the architecture, OpenStack, the reason we selected it is because it really maps well onto that architecture that we talked about around, software-defined storage, software-defined computing, and software-defined networking. And so those are really the primary elements that we're going to talk to you about in OpenStack. There's a number of other features and capabilities in there, but we're going to focus on that. So the core part of OpenStack is a service called Nova, right? So Nova is the part that actually manages all the compute tier. Right? And now the compute tier is where all the applications run, and that's the whole point of being for OpenStack in the first place. So in response, because this thing's an infrastructure as a service cloud, what it's doing is users are requesting virtual machines, and Nova is responsible for provisioning up those virtual machines and then handing them out to the user. But to get started, you got to bootstrap. So taking it from bare metal on up, for us what that means is getting RHEL and KVM and all the OpenStack libraries onto every node. In the future, there's actually this new project in OpenStack called OOO, and it stands for OpenStack on OpenStack. In the future, Nova itself is actually going to be able to install Nova and all of OpenStack onto bare metal hardware. But right now, what you'll see is that different vendors and different users use different tools to actually provision and get OpenStack started. For us, we've been using a tool called the Foreman. We're actually going to show you a little bit of that later. But then once Nova's up and running, its job is to hand out and carve up RHEL VMs. And unlike with Amazon and small, medium, large, we can carve them up of any size you want. But it's important to realize that unlike with virtualization, it's not just about allocating a VM. These VMs are typically released later on. So and then as capacity is actually needed, the Nova tier can actually expand or even shrink. And so that's really what cloud's all about, right? It's really about dynamic, elastic infrastructure. So OpenStack is actually intentionally hypervisor agnostic, so it supports a lot of hypervisors. But in a recent, the Foundation commissioned a user survey, and they surveyed, it was on the order of like 200 to 300 customers just to get a good sample set. And what they found was that far and away, KVM was 71% of all the deployments that they were aware of. And I think that makes a lot of sense. I mean, KVM is really quickly becoming that de facto standard for any time you get the chance to build a greenfield cloud. And I think a lot of the reason for that is just because it really just extends Linux, right, and turns Linux itself into a hypervisor by loading a simple kernel module inside of Linux. And so what that means is that all of those great features, in Linux accrue to the hypervisor. So things like hardware support, performance and scalability, security, and nearly every feature. So at 22 years old, Linux itself, the adolescent Linux has all grown up. And I don't think there's any better sort of testament to the truth behind that than just to talk about how Red Hat Enterprise Linux powers over half of all the world's equity trades. So what you would think of, right, the natural thing would be, okay, Linux is 22 years old, it's very stable, very mature, that technical change and evolution of Linux is actually slowing down. But when we looked at the most recent Linux kernel being developed is release 3.10, right, and that's still underway, and it recently had a 12-day merge window, right, and that's the period of time when Linus accepts changes inside of the kernel, and in just that 12-day window, over 12,000 independent changes were actually submitted to Linux. So it really just shows that the innovation and rate of change inside of Linux has never been greater. So that's really what Nova is all about. And each one of the OpenStack projects has what's known as a PTL, or a project technical lead. And the great part about that is the way, it's really about a land of meritocracy, and that's an elected position. And Red Hat's own Russell Bryant was the most recently elected PTL for Nova, so it's also something we're pretty proud of. On the storage side, there's two core services inside of OpenStack, Swift and Cinder. But there's also a third key one that Red Hat has been driving with the Gluster community, and that actually forms the backbone of Red Hat storage. That's typically something that we add on to OpenStack when we're doing deployments. Each of these storage services are largely independent of each other. They each have their own ways of dealing with availability or resiliency or just scale out. But the first core service that you need, storage service that you need when you're building, infrastructure as a service, clouds of any kind, is really just a boring blob service. And what that really is about is you need to be able to, since they're infrastructure clouds, they're all about launching VMs onto hypervisors. And so the blob storage is really the place in storage where the VMs live before you can actually launch them up. And so that's what Swift does. That's what Swift is all about as part of OpenStack. It provides an object storage that meets that use case. And really the interface to it is really simple. It's really just monolithic gets and puts. And then when data is actually updated inside the objects service, Swift replicates that, but it does it in a eventually consistent manner. So it's useful for putting whole virtual machines there, but you can also use it for other generalized object storage, whether it's, we've seen people using system backups or videos or images. So when you think Swift, it's really analogous to S3, and there's actually common APIs on top of Swift that make it look like S3. But once the operating system is running, right, operating systems need local file systems to actually manage all the namespace of the operating system. So they really want a file system mounted on raw blocks or on volumes. And a lot of sort of cloud implementations use just memory for that. But since that's ephemeral, what that means is that when the virtual machines are restarted, then you lose your past state. So the ideal world is actually a persistent volume service that underlies the file systems used for cloud. And that's what the role of Cinder was. So Cinder is really that storage service for powering OpenStack clouds that provides that volume service. And it was initially actually, Cinder was actually part of Nova, so they were really one thing. So when the two projects that came together to start all this OpenStack in the first place, they were Swift and Nova, with Cinder embedded inside of Nova itself. So now when you start to think about the apps that you're running, applications often want to speak of just a straight file protocol. And now when you're starting to think about elastic infrastructure and cloud, a lot of times to scale out your app, because of the demand on it, you want to have multiple instances of the same app. So then it's also really important that you have shared file infrastructure sitting behind these apps for consistency. And that's the primary use case of Gluster, right? So Gluster is this distributed file namespace that's plugs really well into OpenStack. It supports multi-tenancy, so that way you can have users that still can have their files in a different security context, which is really important. It has embedded replication in it, as well as geo-replication, and the replication is what's used to actually scale out objects, and that actually scale out files, and that's what gives it both resiliency, but it also gives you multiple copies of files, so you can have greater scalability. And we've been extending it over the past couple of years. One of the things that we've done recently is there's a whole team that's working around trying to make Hadoop workloads run really well on a Gluster platform, so specifically in the MapReduce space. And then in addition to speaking file protocols, we also taught it how to speak both the object protocol that OpenStack uses, as well as the block protocol. So you can just, if you want, just deploy Gluster in Red Hat storage as a unified storage service for OpenStack. So next up, there's better than a vendor, as much fun as it is talking about your own products. Intuit's a company that has done some really amazing things using Red Hat storage, and they do things on a deadline that probably everybody in this room don't have, because their deadlines of April 15th are imposed by the federal government.
Intuit manufactures Quicken, TurboTax, QuickBooks products, and as well as small business unit.
We were in the process of essentially re-architecting our platform, especially as mobile started to become really common, and our customers were expecting to move across devices.
We realized that what we need to do is we need to create this consumer financial platform that promotes open source, that promotes code development, as well as gives ability to developers to basically develop their ideas quickly instead of worrying about operations, infrastructure, worrying about various frameworks and so on.
I think what we've learned over the years in the growth of the company, especially in our business where it's so peaky with the tax volumes, is you really can't have outages. You have to be highly available You have to be able to scale.
Storage is one thing that we take really seriously here. If you don't choose a storage that addresses a lot of your use cases, you actually end up spending much more effort during crunch times. Right from the beginning, we had set of principles around the kind of storage we were going to use. Basically, our high-level principles were that it should be highly scalable, highly available with no single points of failure, as well as performance is also a key aspect of it. Red Hat Storage provided scalability, keeping our system up and running. It also helped us with our multi-site effort, where our sites are active in 2 data centers, and it's something that's not that easy to do, and we were able to do with help of Red Hat solution. We don't have to worry about data growth. We can add more nodes, we can bring up new clusters, and we can just scale horizontally instead of vertically.
I think the big advantage we have now is customers on our mobile devices can seamlessly work across. And so if I'm on my iPad and I finish my TurboTax product, my return is now in the cloud. That enables them to get to their data anytime, anywhere.
So that brings us to Quantum, the third piece. And Quantum is really the interface for all things networking inside of OpenStack. And officially, we need to start calling it OpenStack Networking, right? There's actually a company out there called Quantum. And so what you're going to see is sort of old habits die hard. So you'll see us reference Quantum here and there, but think OpenStack Networking. So what you really need on the networking side is you need a dynamic network, right? A dynamic network that's able to be reconfigured anytime you dynamically place your applications and your data. You know, when you look at traditional networks, they're just far too static, right, to support these dynamic environments. And so you just sort of the legacy models of top-of-rack switches and adapters embedded inside of every node just doesn't give you the flexibility to give you a dynamic network topology. Case in point, just think of the case of sort of one physical server, right? One rack-mounted physical server. You know, historically, that would be one operating system and one application or a set of applications that sat on that server for a very long period of time. Nowadays, in both virtualization and especially cloud, there's a hypervisor in every node, and then there's virtual machines and applications that are being dynamically created and released. So what we really need from our network is we need an agile network that anytime we place our applications on hypervisors, that we can bind them to any virtual network of our choosing. So that's really what Quantum's job is. Quantum's job is to orchestrate that virtual network independent of the underlying physical network. And so it does this by, the first part is like a lot of the OpenStack services, it presents an API to end users and to be able to manage it. And the API in Quantum's case is actually really sort of the basis of how you build these software-defined networking applications. But Quantum doesn't try to implement all the logic itself. It actually supports this really rich plug-in architecture. What that allows is you can actually plug in capability into Quantum, whether that's open source or proprietary. In some cases, it's just gateways into physical switches or gateways into whole virtual switches. An important piece of the OpenStack networking architecture is a project called Open vSwitch or OVS. And OVS is a set of user space and kernel modules that actually lives in the Nova compute tier, right? So it lives inside of Linux and it orchestrates KVM. And what it does is it brings into Linux just that concept of virtual networking running inside the host, which is what Linux needs when you're running in a multiple VM environment. So in addition to that, there's this really emerging space of these software-based distributed network controllers. And these new class of network controllers are being deployed typically in these large-scale cloud environments, most often with OpenStack. And their responsibility is to actually manage the whole control plane of these distributed virtual networking environments. We all know about Nicira MVP. We showcased them last year. They were really a really strong pioneer in this space. And there's a lot of other ones emerging. Big Switch Networks has an open source platform. NTT also has a platform. There's over a half a dozen of them that plug into OpenStack Quantum already. A new foundation launched very recently, as well as a new community underneath that foundation called OpenDaylight. And what OpenDaylight's goals are is like, how do we as a community and a set of companies come in and govern and build a software-based open source distributed network controller. a friend and colleague at Red Hat, Chris Wright, he's an engineer that just gets involved, and his roots go back into the early days of networking technology, kernel technology, and most recently he's been spearheading Red Hat's work in OpenDaylight.
There's exciting change happening in the network industry right now, moving from vendor-centric solutions to open solutions, APIs that allow for programmatic change to your networking infrastructure, all in the context of adapting to the requirements placed on the infrastructure by cloud computing. My name is Chris Wright. I'm the Technical Director for Software-Defined Networking at Red Hat. It's been probably 2 years at Red Hat where we've been defining for ourselves the problem statement, which is how do we manage networks in a cloud context or a virtual context. It's that mindset that brought us to the OpenDaylight project. That's an exciting part of the industry. So the networking in general has not been moving at the innovating or changing at the same pace as the rest of the industry in response to virtualization. Now we're seeing a variety of solutions, people who are looking at pushing more and more of the fabric or networking infrastructure's intelligence out to the edge, and equipment providers who would like to see their portion of the industry or the market to remain relevant. The OpenDaylight project is an industry consortium whose goal is to produce an open source software-defined network controller. So an SDN controller gives us an API which allows us to programmatically control the network infrastructure, giving us the ability to accelerate or rapidly respond to the dynamic workloads that come along with cloud computing. One of the needs driving the network transformation that we're seeing take place is the ability to fundamentally decouple your application workloads from your physical infrastructure. We saw that play out in server virtualization, and we're seeing the same thing happen in network virtualization. You break down the barriers to rapidly adapting to dynamic workloads. OpenDaylight and OpenStack are connected via the Quantum project. So Quantum provides the networking services for OpenStack. It relies on some underlying infrastructure to actually manage the real networking elements in the data center. OpenDaylight is that project that can manage the real networking elements in the data center as driven by Quantum. In the next year, I think from the OpenDaylight project, we'll see a functioning controller, we'll see integration with projects like OpenStack and Quantum, which is particularly interesting to Red Hat, and we'll see a number of different layers sitting on top of that initial controller that we hopefully will see released from the OpenDaylight project within this calendar year.
So there's a lot of new projects that are finding their way, into the OpenStack community, and so the technical organization of OpenStack and the foundation recently came together to try to discuss sort of like how do you sort of deal with new project introductions in OpenStack, and how do you actually deal with sort of their evolution. So you're going to see this nomenclature of an OpenStack project, and what that largely means is that a developer chose to use the OpenStack community tools and processes, right, to host their OpenStack project. But then projects after that can actually graduate, and the first level they can actually graduate is the technical committee votes that they want to integrate that project, and by integrating it means it's reached a level of robustness and community participation, and the technical committee really wants to have it as part of every OpenStack release. And then the third part of that is the notion of a core designation. And an OpenStack core project means that the foundation itself is sort of, anointed an integrated project. So it means it's sort of part and parcel with the OpenStack brand. So in Grizzly, that most recent release, 2 projects actually elevated to integrated status, Solometer and Heat. Solometer is really simple. What it's about is actually how does OpenStack expose all the metrics and data and statistics that make it easier to understand what's going on inside OpenStack and make it easier to manage it. Heat was actually started by an engineer at Red Hat, Steve Dake, out of Arizona. And Steve's view was what he was trying to create was how do you actually think about multi-tiered applications, right? Applications with many complex parts. And then how do you describe that? But more importantly, all the resources that application needs. How do you configure those resources? Everything from IP addresses to storage. And then once you define that blueprint, then you just feed that Heat blueprint into OpenStack, and the application can be deployed. And then a relatively newcomer at OpenStack has a new project is Savannah. It was started by Mirantis, and recently you may have seen some news around like Hortonworks and RedHat and Intel starting to get involved. And Savannah is early, but it's really all about how do you make it really easy to deploy Hadoop on top of an OpenStack cloud. You know, we had a lot of choices on sort of how we thought about bringing OpenStack to market, and I think because we didn't decide right away, over the 2 years that we were working on OpenStack technologies, what we really found was that the OpenStack team was really driving hard on what they needed from the Linux team. A whole new set of features and capabilities and innovation were needed inside of Linux, and especially the kernel and KVM, things like OVS and namespaces, and we just sort of saw that going back and forth. And so it was the first time that we had really ever sort of been in this situation. So what we decided to do was that instead of having OpenStack be its a la carte offering, instead we were going to extend the Enterprise Linux family with a new variant that is dealing with the optimizations and the focus and the inclusion of OpenStack into a seamless platform. But we weren't done there because we think all about community, right? Now we really have, you know, the right model on how to bring it to customers in a stable, certified way. And we have this really robust development organization in the OpenStack community, but what we felt we needed was something in the middle, and so we created RDO. And what RDO is our community distribution of OpenStack, and what it's doing is really simple. It's really not trying to be a Red Hat-focused distribution. Instead, what it's doing is it's actually just watching every change that gets accepted into OpenStack upstream, and it's taking those changes out and repackaging them really quickly, not just at the end of the release, but all the way through the release. So, and then it packages them so they can be easily installed on Enterprise Linux. So what that means is through RDO, people can actually, you know, in real time grab the latest drops of OpenStack, and that allows us to get it into the hands of millions of users. So with this, IT is now able to build these private OpenStack clouds that can actually deliver Elastic services. And so developers aren't waiting on hardware anymore. So instead what they get back is they get virtual machines, right? So instead they have to become virtual machine experts. They have to deal with operating system deployments and configuration and cloud APIs. So still not nearly as efficient as they could be, even though they're waiting less. And so as long as the developer is not super efficient, then the business is not going to be as efficient as it could be either. I think the example that embodies this the best was actually told to me by a company that I visited at the end of last year, and really just called it the Hello World example. And what they were trying to do is they were trying to analyze not just their development process, but also their deployment process. So they were really taking an outside look in at how efficient they were. And what they found was they just took the most simple of example, in this case the Hello World example, right? So developers know that's just pick your language and make it print out or show on the web Hello World. So that application, the woman that developed it, it only took obviously an hour, right, to develop it. But what they found is then the next part of the test was to get that application up and running on that company's public infrastructure so that customers and users outside that company could access it. That part took over 60 days, right? So for an hour to develop, 60 days to get a simple application deployed. And really what you want is a model like this. You want a model of continuous deployment. So you really need to get the tail of all that complex application deployment out so that you're really focused on developers and you really get an agile model. And that was really what the inspiration was behind OpenShift. So OpenShift wasn't Red Hat saying we need this thing called a platform as a service, because to be honest, 3 years ago, I don't think we even knew what a platform as a service was. But we did know was that there was a great opportunity to make our developers and other developers ridiculously productive when they're using private cloud and public cloud. And so what we wanted to do is that, you know, we see it, developers are developing over here, and then IT is actually deploying over here. And what we want to do is marry those two environments, right? Get IT and developers to agree on a common platform, not just for developing, but for deploying those applications. And to us, that's sort of the spirit of what DevOps is, and we're a big believer of the impact that it can make. So we deliver OpenShift as a subscription on-premise, and we also host a service of OpenShift up and running on top of Amazon. It's been going on for a couple of years now, and users have really validated it, because today there's over 1 million applications have been created over time on OpenShift, but right now at this instant it's running over 250,000 apps up and running on OpenShift. And this is just a look at a strobe of sort of statistics last month. So those collective 250,000 apps last month consumed over 13 million Amazon minutes. And I think the most interesting part is sort of, I'm just a big believer in trajectory and trends, right? So Each day we average over 2,000 new applications being created on Amazon on OpenShift. So we want to actually, we have an engineer, Jordan O'Mara, and Jordan's going to show you, because when we're deploying OpenShift inside of customer environments, increasingly they want that on elastic infrastructure. So for us, that means OpenStack. So Jordan's going to show you how things like OpenShift, OpenStack, Heat, and Foreman all come together.
I'm Jordan O'Mara, and I'm a developer on OpenStack, and I work on tools that make it easy to install, configure, and provision OpenStack. The demo we're going to show you today is using the Foreman to set up and configure your OpenStack. And you'll notice that the demo only lasts about 1.5 minutes, and that's because it's just extremely easy to use, and that's how long it takes to get OpenStack set up. After we're done setting up OpenStack, we're going to install OpenShift and Heat on our OpenStack, and we're going to show you how to configure that to enable auto-scaling for OpenShift. Okay, so what we're looking at here is the Foreman host console, and this is going to be basically the view that lets you look at the nodes that you're going to provision OpenStack on top of, and then let Foreman do all that work for you. So let's see how that works. The first thing we have to do is basically decide which node is going to be our OpenStack controller. In this case, we've got our horizon.demo.redhat.com machine. So Foreman has a notion of a host group. So a host group applies a set of Puppet modules to a machine. In this case, all of our OpenStack controller modules. Additionally, Foreman gives you the opportunity to override any of these values that we provide for you so that you can customize your installation. For example, we can edit this email address if we wanted to. We can just set whatever we wanted in there, save it, and then when we ran Puppet on the node, Foreman would apply that setting appropriately. And any of the default values we provide for you, you can override. But let's go ahead with the defaults. So we submit that, and we can see that the OpenStack controller host group is applied. Let's go back and look at our host. You don't even have to go through that UI. You can actually just do it right from here. You can select apply host groups from this multi-select box. And in this case, we want to choose our Nova Compute node. Submit that. And now the Nova Compute node's applied to that demo machine. So as soon as Puppet runs on these boxes, they'll be provisioned. One will have the OpenStack controller node, which has all of your core OpenStack services, and the other has a Nova Compute node, which is ready to be provisioned with instances. Okay, so you just saw us use the Foreman to install OpenStack. Now we're going to log into that OpenStack instance, and we're going to use Heat, and we're going to set up OpenShift and show you how to do auto-scaling inside of OpenShift using Heat. So let's get started. We're going to first log into our OpenStack instance that we just set up. As you can see, we have kind of an empty instance here that doesn't have anything, no instances running. And the first thing we're going to do is check out our stacks, which is something that Heat provides, and we're going to set up a stack for OpenShift. And we have an OpenShift template already that's going to set up an OpenShift node and a broker node as well. So you have to fill in a couple pieces of information here, but the important thing that we want to look at is this node count maximum. That is the key that OpenShift is going to use for auto-scaling. And basically that means that after we install 3 gears on a single node, it's going to request back to OpenStack to spin up another instance for use. Okay, so we can see that the stacks are coming up. So let's go ahead and fast forward through that, and we'll take a look at our instances. And you can see here that we have one OpenShift broker and one OpenShift node. So let's go ahead and take a look at the OpenShift console. And for the demo, we're going to use WordPress instances. Each one of these instances uses 1 gear. So after we create the third one, that should trigger the OpenStack scaling event. So we're going to go ahead and create the first one. And I'm going to fast forward through the creation process. So that finished, and we're going to go ahead and log into our WordPress instance. We have to provide a couple initial configuration values just to get logged into the dashboard. So we have a successful WordPress installation. Now let's go ahead and create 2 more WordPress instances on our OpenShift node. And I'm going to fast forward through this really quickly just because the steps are exactly the same as the first one. So creating this third one should trigger the auto-scaling event inside of OpenStack because we've maximized our gear limit. So let's go back and look at our stacks. And what you're going to see here is that it's now requested the creation of a second OpenShift node. So let's take a look at that inside of our instances. And we can see that there's now 2 instead of 1 OpenShift node group. You just saw us use OpenShift along with Heat inside of OpenStack to allow OpenShift to automatically scale out based on your application's demand. So what you just saw is us using the Foreman to get an OpenStack installation started in under 2 minutes, and then using Heat with OpenStack and OpenShift to automatically scale out your applications.
So at the end of last year, we announced the acquisition of ManageIQ, and what we've done is we've taken the ManageIQ technology and we've slipped it into our CloudForms product. And really what that's about is, what CloudForms is about is it's really about adding key capabilities on top of either virtualization or cloud platforms. You know, things like, you know, all the additional things that you need to manage, and preferably in a consistent way. Things like monitoring cloud resources, resource utilization, roles, privileges, chargeback. In addition to that, CloudForms actually, what it does is it actually provides really a unified console in front of these clouds, whether it's, you know, multiple public and private clouds. And it does so in a cloud agnostic way, in that it actually works on top of Red Hat Enterprise Virtualization, it works on top of VMware, works on top of Amazon, and obviously now we're working to make it work on top of OpenStack. So really, through open source software, I mean, it's hard to argue that RHEL, KVM, OpenShift, OpenStack, Red Hat Storage, CloudForms, they really are redefining IT. You know, I think it's the first time that developers have a DevOps platform that not only can they develop quicker, but they can actually deploy in real time. And because of that, it's the first time there's 0 latency on getting new applications and capability onto the front of businesses. And so really, you know, the lines of business can really start to really compete and drive customer engagement and innovation. And now, instead of IT being in the way, IT is actually the enabler of all this, right? IT are the ones that are actually building these integrated infrastructure and platforms as services and providing them together as a single platform. So I think we've sort of reached that day where even as the expectations, you know, go ever higher on IT, they now have a platform where they can meet those expectations. And they've done it not just by spending more dollars. Actually, when they get there, they've done it by, you know, creating massive efficiencies in both OpEx as well as CapEx. They obviously have to continue to manage the legacy, but no longer do they have to do that at the expense of new innovation. And really, you know, I think that's the best example of sort of, you know, technology evolution and business transformation really working together. And I think that's would have only been possible because it was enabled by open source to allow for a model of worldwide collaboration at this massive scale. So thank you, and I got a couple of housekeeping notes before you guys take off. So we had to make a couple of changes. First, at the end of the day here today at 6 o'clock, right back in the general session, if you've been out around, you'll see these banners of all these innovation nominees, and so you'll see customers doing interesting things with open source and Red Hat technologies. Come back in here at 6, and you're going to actually hear a lot more of the story of these, and we're going to actually, Jim Whitehurst, our CEO, is going to actually be handing out some awards. And then also, so that'll be about 6 to 7. And then at 7:30, we've had to move the venue of the party this evening. Instead of being down in Quincy Market, we're going to have to pick an indoor location. So at 7:30, it's out on Boylston, so right out here. There's buses at 7:30. And then there'll be buses back. But I think at the end of that, for those of you that have a lot of energy, there's actually, the pub crawl will kick off at the end of the party. And the party is at a place called the Royal Club and Lounge, and it's sponsored by IBM, so we want to thank IBM. Thank you.